So now you've run a independent two-mean t-test and you've got your result. But then there's another thing we can do with those results. We can see the effect size of the difference that's going on. So we have something called Cohen's d, which is a measure of the effect size based on the differences between the two means. So let me quickly explain the differences between two means. So say that your average salary every week is $1,000, and say your best friend's average salary every week is $1,500. So then the difference between your average salary and your best friend's average salary is $500. Well, we don't really know. Is that a big deal? Is that a small deal? We don't know. This kind of thing called Cohen's d lets us know how big, small, or medium the effect is. So again, what are we doing? We're looking at two populations. I'm looking at the differences to see if the differences that are going on, what size that effect is. Because think about it, small effects may not be a big deal. Large effects could be huge, and we need to look at those. Even medium effects could be big. And again, I did just discount small effects, but what if you're looking at like breast cancer survivors, or you're looking at some kind of medical thing, while it may not make huge deals, but it makes a small effect that could save people's lives. That's when you kind of have to step back and judge, maybe a small effect is a good thing because you're showing some kind of promise that puts you on the road to doing something bigger. So Cohen's d is named after a statistician, Jacob Cohen, and it measures the relative strength between the differences between the means of two populations based on the sample data. That was a mouthful, so let me say that again. So it's telling me the relative strength of the differences between the averages of two populations in regards to their data. The calculated value of the effect size is then compared to the Cohen standard of small, medium, and large effect size. So small is anything between 0.2 below, medium is 0.5. So remember, you could have a small to medium effect size, and you could think it'd be 0.35. You can have large effect size, which could be anything 0.8 or over. So just make sure that you know those things. Another thing, what if my Cohen's d value is negative? Well, the calculated value of the effect size is compared again to the small, medium, and large, but now sample 1 has an overall average than sample 2. So, has an overall lower average. So think about, I might want to do students who did class 1 students who did a different reading program than students in class 2, but maybe for students in class 1, them not getting the intervention, their reading score stayed low, but for class 2, they went up. It could have a negative effect of not having that reading intervention given to them. So again, same scale, I just have a negative number about it and talk about it's lower, something's going on to make it be lower than the other thing going on. So how do we get the Cohen's d? It's really simple. Minitab already gives it to you. So remember that part I said we're going to come back to it in Minitab, and I'm going to show you right fast. I'm going to push it so you remember. So remember I had my descriptive statistics, and I said, hey, estimation for the difference, we're going to come back to it. We came back to it. So here, if I go back to it here, okay, so I have it. I have the difference, which is 0.500. I have my pooled standard deviation, which is 1.302. And I'm going to use both numbers to calculate my Cohen's d. So you're going to take the estimate of the difference divided by the pooled standard deviation, and I get 0.384. So the effect size is small because it's 0.384. I'd say it's small. You could also say small to medium. That's fine. So what this tells me is the size of the differences of the means for the two colleges is small to medium, indicating there's no significant difference between them. So remember that you even did in the initial question, you didn't find it was significant, but you still want to report that Cohen's D. Because even though it wasn't significant, you still want to talk about it because something could be going on.